Hi everyone. So today is day 15 of September LeetCoding challenge, and on this day we have to solve this longest turbulent subarray problem. And in this problem, like we have been given an integer array ARR, and we need to return the length of a maximum size turbulent subarray of this array. So a subarray is turbulent if the comparison sign flips between each adjacent pair of the elements in this subarray. So what does it mean? So suppose we are choosing a subarray from index I to index j. So this array will be called turbulent subarray if it is either fulfilling this condition or whether it is fulfilling this condition. So there are two conditions, right? So the first condition says that if k is odd, then this element at index k should be should be greater than the element at index k plus 1. So basically it means that if the index is k, then this element at index k should be greater than the next element. And if the index is even, then the element should be smaller than the next element. And the second condition is just opposite. So if k is even, then the element should be greater, and if k is odd, then element should be smaller than the next element. So in terms of representation, if we will draw the array, so if we are considering this zero based indexing, then the type 1 array should look like this. So for type 1, like if k is even, then the element should be smaller, and so this would look like this. And this type 2, so if k is even, then element should be greater. So this type 2 turbulent subarray should look like this. So these are the two types. For solving this problem easily, we can consider these two types of subarrays independently. Like we can find the maximum turbulent subarray for type 1 and maximum array subarray for type 2, and then we can take maximum of these two. So we will solve it. So the naive approach for solving this problem will to consider all the subarrays, so that there will be minimum subarrays, right? We can we can select two indices out of these n indices, and that will give us a subarray. So there will be, so any two, we can also select this same one element subarray. So there will be n into n plus 1 by 2 subarrays. Basically it is nc2 plus n. So these n represent the one element subarray. So there will be n into n plus 1 by 2 subarrays, and out of these all subarrays, we can check whether the subarray is turbulent or not. So for checking, it will also take n iterations in worst case, right? So that will be order n cubed solution, and seeing the constraints, we can see that the solution won't be able to pass all the test cases. It will give us TLE. So we need to optimize, right? So for optimization, we can use a result, right? So this result is that if we know the maximum size of turbulent subarray ending at a particular index, we can, so suppose we want to know the maximum size subarray ending at index I. So this is index I, and we want to know this subarray size, maximum subarray size, which is turbulent and which is ending at index I. So we can easily write this. So suppose it is dpi. So we can easily write this dpi in terms of dpi minus 1. So just in case it is these the previous element and this element are fulfilling this condition, then we can take the maximum subarray size till index ending at index I minus 1, and we can add 1 to it to get the dpi. So this dpi will be dpi minus 1 plus 1 if the condition is getting fulfilled. So how we can do this? Because suppose there was a subarray of size x which was turbulent, right? So it was fulfilling like these elements were fulfilling all the conditions. Now if these two elements are also fulfilling the turbulent subarray condition, then we can extend this array. So that's why like this dpi is equal to dpi minus 1 plus 1. And just in case this condition is not being fulfilled by these two elements, then we can set dpi equals to 1, because we can only include this current element in this turbulent subarray, and we can always include one element to the turbulent subarray. An element and subarray with only one element is always turbulent. So that's why we cannot extend it further, because this condition is getting is not being fulfilled. So no matter how much array we are considering, no matter how much conditions are being fulfilled, this condition will not be fulfilled. So we won't be able to like consider any subarray greater than of size 1 ending at index I. So this dpi will be either equal to dpi minus 1 plus 1, or dpi will be either equal to 1, depending on this fulfilling of this condition of this I and I minus 1 element. So we can use this approach to solve this problem. So we will make a dp array for type 1 turbulent array, and we will make another dp array for type 2 turbulent subarray. And since we are using this dp thing, dp like vector, like the space complexity will be order n. So we can have a look to how we can further optimize this space complexity. So first of all, we can implement this solution. So we can get rid of this diagram. So for implementation, I will first consider the size. I will store the size of this array in vector n. Now we will need a dp vector. So I will initialize it with 1. And now we need to iterate from I equal to 1 to I less than n, I plus plus. At every step, we will be considering, we will comparing the elements at I minus 1 and element at I. So we are considering the current element and the previous element. So for the first turbulent array, like if I minus 1 is even, right, then this array at I minus 1 should be smaller. So if it is smaller, then dp of I will be equal to dp of I minus 1 plus 1. And if it is not, then dpi is equal to 1. And similarly, for odd parity, the condition is just opposite. So we can just copy and paste this thing, and we can reverse the condition, right? So this thing will calculate the value of dp, and we can take maximum subarray size of them and store it in the answer variable. So we again need to consider the turbulent array of type 2 for the overall answer. So instead of using another dp vector, we can reuse this vector, because at every step we are recalculating the value of dti. So we don't need to reset it, it will still work. And this dpi will, dp0 will be 1 in here also. So we don't need to worry, because it is already set to 1. So we can again do all this thing. Only thing is that we just need to reverse these two conditions, because in type 2 these conditions are just opposite. So we can again take the maximum of this new dp vector to get the answer. So this will give this will like return the maximum. And we can return this answer. So the time complexity is order n, because we are iterating over the arrays n times. and space complexity is also n because we are using this TPL like vector of size n. So we can run it. Yeah, it is working on the sample test cases. We can submit it. We will optimize it after. Yeah, so it is working, so we can optimize it. So we can see that at every step we are using only the previous value for calculating the current value, right? So we don't need this whole dp vector. We can only take a variable current and we will initialize it to 1 because this dp0 is 1, and we can, so this will be old current, and now this new current will be changed to current equal to current plus 1, and this new current will be changed to 1. And in the end we were like taking maximum over this whole dp vector, but now we don't have the whole maximum, so we can keep updating the maximum, the answer variable after calculating every current. So I can have something like this: answer will be max of answer and current. So we can also have this line below this also, but the answer is already equal to 1, so it won't matter. We can get rid of this thing, and we are resetting this current to 1 because this dp0 will again be 1, and we can have current here also. So after this change, the space complexity has now become order 1, and time complexity will remain the same. So after execution of these two loops, we have got the answer. So we don't need to do this now. We can check whether it is working or not. Everything looks correct. We just need to get rid of this thing. Otherwise, space complexity will still remain same, right? So now everything looks fine. We can test it on the sample test cases. Yeah, it is working. We can submit it. Yeah, it got accepted. Thank you guys. See you on day 16. Until then, keep leet coding.